Okay, so we'll do our homework today and then we'll do some practice work on functions.
Mm,
All right. Okay, let me
mm.
share my screen, bring up the homework. Okay, Latoya, you see the homework? Functions homework? You see that?
Yeah,
Okay. First problem is, oh, I know you got that one.
I said C,
You say C.
but that was my first answer. But that's
Okay.
not the right answer. The answer is D as in dog.
You say the answer is D. Okay, let's read through it. I think you're just guessing, Latoya, right? You're not
No.
reading through it. Okay, let's go.
Oh, I got it now. It's B. Why am I saying C? It's B.
Well, you've
Why
eliminated all
did
the
I say
wrong ones.
C?
So the right one, all the
No,
ones you
it
said,
was B. No, first thing it was B. Why am I saying C?
it's not B.
Well, I give up.
No, you only have one left, Latoya. By default, it has to be what?
So you want to tell me it's A? How is it A?
That's it. It's A. Okay, let's go through it. At Joe's Pizzeria, a pizza costs $5 with the first topping. That's your key right there. $5 with the first topping. That means only after the first topping do you start paying the 75 cents, right? So if X represents the number of toppings, what function represents the cost of a pizza with at least one topping? So you've already got one included, right? So that's why you've got to subtract it out here before you multiply it by the 75 cents. Got it?
Yeah.
Latoya, you following? You see,
Yeah, but how do?
you've already got one topping along with the $5. So it says at least one topping. So if you had two toppings, how much would you pay?
X minus 2?
No. What would be the total cost of the pizza if you had two toppings total?
150?
No, you're going to pay $5 right up for the pizza. You're going to pay the $5.
Oh, so it's
So it's going to
plus
be
10?
5 plus what?
5.
5 plus how much? You've got two toppings.
Oh, 0.75 cents.
That's it. 5 plus. So your pizza will cost you $5.75. Because see, one topping is already in there, right? So if the pizza has two toppings, you've already paid for one when you paid the $5. So you only have one. So it's total of two. 2 minus 1 gives you 1. 1 times 75 cents. So you see how this works, right? And if you had 4 toppings, how much would you pay? At the math. What would be the cost of the pizza if you had 4 toppings?
4.75?
No, but it's got to be at least 5. Can't be under 5. It's got to be over 5, Latoya. Remember, whatever you get for the toppings, you'll add to the $5.
9.75.
How are you getting 9.75?
Because I add 4 to the 5.
Latoya, let's
I'm not getting this.
I know. Let's just go back. Okay. $5 includes one topping. All right. 75 cents paid for additional toppings. All right, so if you had 4 toppings on your pizza. Now, how many toppings are you paying for?
4.
The $5 has the 1 topping. So how many are you paying for?
5.
Wait, Latoya. 5, you have a total of 4 toppings on your pizza. Total of 4 toppings on your pizza. Right up front, you're gonna pay $5. So let's just put the $5 here. Now that $5 includes 1 topping. So you're paying for 3 toppings. So what's the cost of 3 toppings?
At 75 cents.
At 75 cents. Yes.
It's $3.65.
It would be 3 times the 75 cents, right?
Yeah.
So that would be equal to $5 plus, and 3 times 75 cents is what? 225? 225. All right. So that would be equal to a total of $7.25. You're getting it?
Yeah, I guess so.
See, and that notice how we got that. We got that with this function. Let's just copy that function. All right, let's copy that function there. And if you had 4, and let me just copy it over on the other side. Okay.
Oh.
That's somebody on your side about Band-Aids? Okay, so you take that, you have 4 toppings, right? So let's just copy that and put in our 4. So that means you take your 4 and put it for the X, because that's the total number of toppings I said you had. And 4 minus 1 is 3, and 3 times the 75 is 225, and you add it to the 5 and you get the 725. Is it making sense, Latoya, now?
So
if you had 8 toppings, to give you a chance to figure it out, you have 8 toppings, what would be the cost of your pizza? 8 toppings. Cost of pizza. I remember you use that same equation because the answer here was, this is the answer right here, right here. That's the answer.
what, 75 cents?
No, that's the function that you can use to calculate to get the number of the amount you pay if you had 8. So you're taking this same equation right here, and where you have X, put 8. I don't think they even have a choice of 8, but I just wanted to put a big number here. So if you had 8, put an 8 here for the X. So you put an 8. And 8 minus 1 is what?
7.
Now multiply the 7 by the 75, and what do you get? 7 times 7, 75.
525.
So that would be a 7. And 7 times, let's see, 5 and
525.
525. That's right. So it would be how much? How much would the pizza cost?
$8.25.
What are you adding, Latoya? You just told me this was 525, right?
Oh, and 8:30 and 25. Sorry.
Then what kind of math is Latoya doing here? I know she's a whiz with this
I
stuff.
haven't get enough sleep.
You sounding sluggish.
Yeah, I do.
Okay, that's what, 525 you said, right? So you just take the 525. and add it to the $5. And that gives you 1025. Let's just put it here. So that means that pizza would cost you $10.25. So functions are used in the real world, like this kind of thing. Also, like if you in the taxis, like you pay an upfront cost and then you pay so much per mile. That's a function. That's a function that includes the change in the well, actually it's the slope, the cost per mile, say, and then the fixed is that cost you paid it once you get in the cab. You're going to pay that regardless of how many miles you travel or blocks or whatever. Okay. Now, is that clear now, Latoya? Why it has to be A?
So we take 1 minus 8 makes 7.
Yeah, if
So
you
it's
take the number of toppings, subtract one from it, the reason you subtract the one because the $5 includes the first topping.
okay.
So any additional, you multiply by the 75 cents. So that's why you subtract out the one, because now if it didn't include it, then you would put the whole number here. Like if it didn't say the $5 with the first topping, if it's $5 with no toppings, then you would put whatever the number of toppings times the 75 cents. Got it? Question? Is it clear now? I don't want to leave it, Latoya, if you're still puzzled.
Yeah, I understand that part.
You understand it?
So you
Okay.
gotta subtract it.
Yes, and that's because of the $5 with the first topping statement right here.
So if they say 2 toppings cost $1.50, where
Well,
you put it out for this?
two toppings is going to be 75 cents for one topping, because remember the $5 already has one. So it'll be $5 plus what? 75 cents.
No.
Right?
Then suppose it was included, you have to charge the regular price.
If what?
If no topping was included.
If no topping was included, then whatever your number of toppings is, say it was 3, you're going to multiply it by 75. So, Audrey's coming on. Audrey. Is that Audrey? I haven't seen Audrey in a while.
Yeah.
Audrey. I know Chastity is, well, I don't know. She may be traveling. I see her there, but she might be traveling. Audrey. Hello, Audrey.
You're on mute.
She connected the audio. She would, yeah. Audrey, you're on mute. Audrey, unmute yourself. Audrey, unmute yourself. Turn your mic on. Audrey? Hello? Audrey, can you hear me? Audrey? Hello? She's there, but she's not there. Audrey? Hello? Okay, well, let's continue. Maybe I'm surprised she doesn't hear me and she's there. I mean, I see she's on mute, but
Mute.
Hello, Audrey.
Yeah,
Oh, you can hear me good. Now I can hear
I now
you.
hear you. Yes, you tell me to unmute, though. I was looking for it.
Okay. All right. How you doing? Long time no hear from
I'm,
you.
I'm good. I'm good. I
Good.
haven't done anything since I spoke that, since I sent that note to you. I haven't done anything.
Okay. Well, we're
But I
doing,
have to go. I have to check that function information.
yes, I sent it all email and also I put it on YouTube.
Yeah, so I have to go through that. I haven't done anything.
Well, you go to YouTube, so because we're taping it and recording it, and I put all the sessions that we're going through right now on. I send email, so you can
Oh, okay.
really go back through it. So what we were, let's just go back over this. Let's see. Can you see the screen, Audrey? Audrey?
Yes.
Okay.
Yes.
So read number 1.
You mean the introduction or the homework?
Right here, number 1.
At Joe's Pizzeria, a pizza costs $5 with the first topping, and then an additional 75 cents for each additional topping. If
Keep
X represents the number of toppings on a pizza, what function represents the cost of a pizza with at least one topping?
Okay, now we went through it and we got the answer A.
A?
Yes, can you tell me why A is correct? This is a slope intercept format, except the f of x of the function is like our y, right? And then we have mx, so the slope is the 75 cent, and we have the x, and then the fixed cost is the $5 for the pizza with the first topping. All right, so it's really in the format of y equal mx plus b, except instead of y, we call this function of x, where this is your output and this x is your input. So can you tell me why A is correct?
X is the input.
Yes, and f of x, now this is equivalent to our y. Our y is our output and x is our input. Why is this equation correct for what we were given?
I actually see to understand this, you know. You see, this will always give me trouble doing it. I will have to go through this work and read over everything to understand this.
Okay, now, Latoya, can you explain why A is correct? We went through it. Explain to Audrey why A is correct.
Well, why A is correct is because one of the topping is a $5 for the pizza, and then the topping is included into the $5. So the cost of each additional topping was 75 cents. So you're gonna have fx equal 0.75 with parentheses x minus 1 plus close parentheses plus 5. That's how you
Yes.
write out the word prop. You write out the answer.
But there's only one topping.
Yes. But
yeah, one topping is included, but they have 75 cents. One topping is included in the $5, and then for each additional topping is 75 cents each.
Is it making sense, Audrey? Good explanation, Latoya.
I don't understand it.
Yeah. So okay. So 75 cents for each additional topping. That's why you have to multiply the 75 cents by the number of toppings. But Audrey, if you got at least one topping is included with the $5. So whatever number of toppings you have for your pizza, you've got to subtract one from it because one is already included with this $5. That's why the subtraction. That's why you can't just multiply 75.75, that's 75 cents by X, because one topping is already there.
Mhm.
So if you had two toppings on your pizza, this would be 75 cents times 2 minus 1, which is 1. So your cost of your pizza would be $5 plus 75 cents. You wouldn't pay for the 2 because 1 is already in that $5.
Well, you were saying that where the X is and it was a 2.
Yes, you had 2 toppings. 2
Uh-huh.
minus 1 would give you 1. So you only pay for 1 additional. You following? If you had 2 toppings, you'll only pay for 1 additional because 1 is already included, which is why you subtract it out. If you had 3 toppings, you'll only pay for 2. That would be 2 times 75 cents, $1.50 plus 5 would give you $6.50.
Mm.
Audrey, is it making sense?
I think so.
Yeah.
I didn't really
So,
get it yet.
yeah. Well, here's your key right here in your word problem. $5 with the first topping. That means after your first topping, you're only going to pay for the ones after that first topping. So 4 toppings, you pay for 3 additional. 5 toppings, you pay for 4 additional. All right. What would you pay if you say, I don't want any toppings? What would you pay, Audrey? What would be the cost of your pizza? You say, no additional topping. Audrey? Audrey?
What?
If
How?
you ordered the pizza and you said, I don't want any additional topping, what would be the cost of your pizza?
$4?
How much?
$4?
Where are you getting $4 from? What does your pizza cost with 1 topping?
$5.
So where are you getting $4 from?
I subtracting the 1 from that because I said they want the topping.
No, but why are you subtracting 1? I want the pizza that comes with the first topping. I don't want any additional. So I only pay $5.
Mm.
You follow?
Mhm.
I ordered a pizza. I don't want any additional topping. I only want what comes with the $5. So that's 1 topping and I pay $5. So if I say no additional toppings, what would that be? 1 minus 1 is 0. 0 times 0.75 is 0 plus 5. I pay $5. Got it?
Okay. Think
Okay.
so.
All right. So no.
Yeah, this was always hard for me to do. Even when it was going at the other classes, it was a kind of hard.
Yeah. Okay. So that's why I'm going through it. We'll make sure you understand it. So whatever number of toppings you put in here for X, you'll get the right answer. So if you
So
say
you're doing the parentheses first?
yes, you remember PEMDAS, you got to do this first. 0.75 times the X minus 1. Okay. So no additional toppings. 1 minus 1 is 0, right? And 0 times 0.75 is 0.7 is 0, and plus 5 is 5. So just a straight pizza with just the first topping that comes with it is $5. Got it?
Okay.
Okay. Audrey, 3 toppings. What would my pizza cost?
$15?
Where are you getting 15?
I still didn't understand that.
Okay. 3. Okay. 3 additional toppings. What would 3 additional toppings cost? Audrey, what would 3 additional toppings cost?
$2.25?
What would it cost?
$2.25, Miss Barbara.
$2.25?
Mm-hmm.
Okay,
Because it says an additional one is 75 cents, so a 3 would be 225.
okay. Three toppings. Okay. 3, 10, 75 equal $2.25. Okay. Okay, that would be 225 for the additional toppings. But if you say 3 additional, you have how many total toppings on the pizza? You have 4, right?
4 here.
So the X here would be 4. And then
Mhm.
4 minus 1 would be 3. And then 3 times the 75 cents, like you say, 225. That's right. So you add that 225 to the $5 and you get $7.25 for the cost of the pizza.
So the 75 will be multiplied by the 4, 0.75 will be multiplied by the 4.
Well, if in plugging it in the function, see, you say 3 additional, that means you got 1 topping and 3 additional is 4. So then when you put the 4 in here minus 1, you get that 3 that you did when you multiplied it, right? But that's because your total number of toppings, X, was 4. The 3 additional plus the 1 that comes with it. Okay.
Okay.
So that means you'd have to substitute 4, the total toppings, which would be the 3 additional plus the 1 that comes with it. Any questions? But like you said here, 3 additional is 75 cents, that's 225, and you add that 225 to 5 and you get the 725. But you only get that when you have this f of this function, right? Because you wouldn't get this with any of these others. The only other one that has 0.7, well, nothing has 0.75x. This one's 75x. So the only 1.75 is right here, A. Now, if I just asked you the cost, what would be the cost, and gave you a multiple choice, then of course it would be easier because you, like you just said, 3 times 75 cents is 225, and I add that to my 5. My cost of my pizza is 7.25. So if I gave you some, series of numbers, you could pick out the number. But I want you to be able to find the function that represents this, because we're doing functions now. Okay. Any questions on number 1? Okay, let's go to number 2. All right. Okay, number 2. Can you see that? Should I make it bigger? Make it bigger, 20. Okay. So the total cost of airfare is what? Base cost and the fuel surcharge. All right. So the total, let's just write that here in words. Total cost okay, this is total cost of the airfare. Okay, total cost of airfare is equal to 2 things. And what's one of them? One is the base cost. That is C, represented by C. Plus what? What's added to that? Audrey? We have 2 things, I'll underline them. Base cost and the fuel surcharge.
Surcharge?
That's right. Those are the two. So it's base cost C plus fuel surcharge. And we call that what, S? Okay. Okay, so that's the total cost. Now, the base cost is a function and the surcharge is a function, right? So we're given, let's just write what the base cost. That's C, and they're all a function of what? Miles, where M is miles. Okay. I don't know. Okay, so C of M, they give you that in the equation. Here we are, right? They give you that in the problem. C of M equal, let me just underline that. The cost is equal to what? 4/10 times the number of miles. So that's equal 4/10 and the number of miles plus 50. Decimal point here, 4/10. And what is the surcharge equal to, Audrey? What is the surcharge? That's based on miles too.
That's a third.
Well, it's 0.03 M.
0.03 M.
Zero. Okay, so that's equal to that's equal to 0.03, 300ths time M. All of these are related to miles, right? Okay, so we have the total cost, base cost plus surcharge, and they're all in terms of miles. That means if we could find what the cost is for the 1,600 miles, find the surcharge for the 1,600 miles, add them together, we can get our total cost. Got it? So the function of the total cost is going to be equal to the sum of these two, right?
Mm-hmm.
So the function of the total cost, and I'll just say F of M, where F of M is really the total cost. I'm translating these words into a function. So F of M would be equal to C of M. Okay. So that's equal to C of M plus S of M. And we know what those are, right? Because we've got our values there. So substitute those expressions into this equation, right? So let's do that. Let's take the F of M. That's the total cost. That's the output. Okay. And I put this here. Now C of M is 0.4 M plus 50. So I'll just take this and put that in for C of M. So let's just put that here for C of M, substitute. Now, actually, I'm going to put this all on the next page so we don't have to break it up. So I substituted in for the C of M, which is 0.4 M plus 50. Plus, okay, so that's 0.4 M plus 50. And this would be what? Plus, then I put the S of M. and the S of M is 0.03 M. Okay. This is decimal, 0.03 hundredths. Okay. Now F of M, remember I told you that's the output. That's the equivalent of what we've been calling Y. Okay. So combine these. What do you get when you add 0.4 M plus 0.03 M? What does that give you?
.4 M.
Now for
and
the
zero, are you adding 0.03 M?
yes, you add this, but now it said when you flying 1,600 miles, right? So when we add this up, I can put what that is because they gave us this 1,600 miles, right? So let's put our 1,600 here. All right.
Hey, how are you guys? I'm sorry, I just got home.
Okay, Chastity, we're doing the homework function problems. We're on the second one.
All right, thank you.
Okay, so we have 1,600, and let's just put here, because we were given that they're flying, what, 1,600 miles. Okay, so all of this is equal to 0.4 M plus 50 plus, and Audrey, you added that together, and what did you get?
0.403.
Yes, 0. Okay, so this, let's just copy that, and because you combine in the 6, the 4.4 M plus the 0.03 M. Okay. Just put that there and put what you said that when you combine those like expressions. Okay, so that would be 0.43 M when you add the 0.03 M to it. So this will just be 3. We take this out because you added it, right? Okay. Now, Audrey, what would I do next?
Oh.
What would I do next?
Find the total cost.
Well,
By
wait, I'm sorry. Okay, this is 0.43 M. This is, that's not. This is actually total cost. Maybe I should use a T. Well, no, I use the F of M. This is really the total cost that we're looking for the Y. So the miles is what? That's the 1,600. So we substitute in for the M, the 1,600. Okay. Because they gave us that. And multiply this out and add the 50, and what do you get? Let me put this, I'm going to make this T instead of M for total. All right. T. That'd be total cost. Okay, so total. And the 1,600 is the number of miles.
It's 688.
What did you get?
688.
Audrey, what did you get?
I haven't finished it out yet because I got my calculator near to me. So they're doing it by hand.
0.43 times 1,600. What did you get, Latoya? I don't think I-
688. It's not me if it's wrong on the calculator.
Okay. 0.43, let's see, 0.43 times 1600.
I'm just trying to do it on my hand.
Let's see. Okay. 0.43 times 1600. What did you get, Latoya?
688.
What, you threw away your 50?
She showed the four. Yeah, that's right.
Oh, didn't add the 50.
You threw away your 50. Okay,
So that's
so
723.
so you got, let's just copy that. All right. And you got
688.
688.
Yep, plus 50,
That's 50.
plus 703.
50.
So that's equal to what? 738?
738.
No, never said that.
738.
738.
738.
And that's in what they gave it in. It wasn't in dollars, it's in rupees. 738 RUPE. So the total cost here is a function of miles in both the surcharge and the base cost. So we have the two functions here and we add those up together to get our output. And I call it T for total cost. All right. So it's the sum of two things, and they gave you the functions of the cost and they gave you the function of the fuel surcharge. And the problem said the total cost is the sum of the base cost plus the fuel surcharge. So we plug those in. C of M, 0.4 M plus 50. S of M surcharge 0.03 M, combine the M's, 0.4 plus 0.03 gives you 0.043 M, and the number of miles, you want to fly 1600 miles, that's your M, and we get, it would cost a total of 738 rupees to fly 1600 miles for this airfare. Any questions on number 2? So this is a real world problem of using functions where you have two functions that determines the total cost of something. Can you think of something else where you have two functions determine the cost of something else? Anybody? Think of if a plumber was doing work and he said, okay, I'll charge you $50 plus $40 an hour, right? So you've got $50 plus $40 an hour. Well, that's a function that's like the one we just went through, the one where we have the slope intercept, but that's a function of two things. Because a lot of times you pay a base and then you pay something else, right? Can you think of anything you pay a base and then you pay something additional?
Like the car service.
The car service,
Taxes.
you have a base and an additional. Oh yeah, you pay a base and then you pay so much per mile. Do they use time or miles, Latoya?
They use miles, so the yellow cap.
Okay, they use miles. So you have a upfront cost plus you pay additional for per miles. Yeah, that's the way the cabs work. So you may pay $5 and then pay 50 cents a mile. So your total cost is going to be your $5 or whatever it is plus the amount per mile. Any questions? Oh, another one is, how do you figure profit? In generally, how do you figure profit on something?
Like selling price, original price minus selling price over.
No, if you were performing a service to someone and you starting a business and you want to know how much profit, how would you determine your profit?
We start tracking what you charge the person or what you gain.
No, say you were selling bracelets. Okay. How would you determine your profit for selling those bracelets?
Because you're gonna check up the price,
You
how
can
much
calculate
you buy
what the
for,
sales from what you purchased, what you give for the bracelet.
how much is your profit, like if you make 46
Your
cents.
profit is going to be what?
Your profit is what you make after you take out what you gave for the bracelet.
Your profit is your expense from your revenue. So if you
You have to
bought
take it to
those
whatever the-
bracelets, if you bought those bracelets for $15, right?
Right.
And you paid $100 for the bracelets. Now, you'd have to figure out how many bracelets do I have to sell to
To get
make
back that
back
money.
my money, right? So
Yes.
you really have two functions there. You have your bracelet cost function, and you
Mhm.
have your
Expense.
expense function,
Yeah.
right? And you get the difference between those two to find out your profit. And if you to break even, your cost function would be equal to your revenue function. Okay. And to make more money, you'd have to have your revenue function greater than your cost function. All right. So those are like real world examples of using functions, and people don't think of them as functions, but businesses use them all the time, and you use them too. But you just don't think of them as functions. But think of them as input and output. And for functions, we're going to look at some examples with the ordered pairs where you have one input to one output. And we'll look at somewhere you can determine, do these ordered pairs represent a function? Now for functions, we have domain and range. And we just call them, we could call them X and Y. Range is output Y, domain is input X. Okay, so if you were given X's and Y's and they ask you, what are your domains, what are your ranges is going to be all your Y values, and your domain is going to be all your X values. That's for ordered pairs. Okay, but let's just look at a table. Okay, this is part of your assignment. Okay. Now we have domains. This is X and this is Y. And remember, we can only have one Y to our X. If we have more than one, it's not a function. The relation is not a function. In other words, it's only a one-to-one relationship. You don't have several of your X values to different Y values. This X can only have one Y value. Just like this one, minus 14 has 7 for the Y. One has 8, one has 7. So is this relationship a function, Latoya?
No.
No. Why? No is correct, but why?
Does it have more than one domain?
Well, yeah, it has the same domain connected to two ranges. Right. So because you have an X 1 to 8 and you have a 1 to the 7. You can only have, if you put a 1 here, it can only be connected to one range, not two. That makes it not a function. Audrey, you following?
Yeah.
Okay. Because you probably gone over this is a review. Okay. So it's not a function because your relationship shows your X values are domain linked to more than one Y value. You have the domain 1 to 8, same domain to a 7. That means it's not a function. Audrey, table B. Function or not a function? Can you see table B? Audrey?
Mhm. Yes.
Domain, X values, range, Y values. That a function? Yes or no?
I would say no,
You say no, why?
because you have a 6 domain and a 12, and then you have an 11 and an 8 and 11 and a 4. Negative.
But aren't these all different?
Yes, they are different.
So you don't see any duplicates here, right?
No.
No duplicates, so this is a function. See that minus 11, 11 are different. They're different
one
X
is negative, one
values.
is positive.
I'm sorry?
You say one is negative and the other is positive.
Yes, but they're not the same. Minus 11 is not equal to a plus 11.
Hmm.
They're different values. So function, yes, because every X value has its own unique Y value. See, you don't see any duplicates. Like up here, we saw duplicates. So the key is, if you don't see duplicate X values here, then it's a function. Okay, no duplicates. The fact that the signs are different, and they're the same number, they are different. They're not the same. So this is a function. Questions? Now let's go to ordered pairs. Now remember, ordered pairs, they come X and Y, right? X followed by Y. So that means X, Y, X, Y, X, Y, X, Y. Now, Latoya, which of these following sets of ordered pairs represent a function?
A.
A, that's correct. You just look for your duplicates. You don't see any duplicate X values. You see 3, 5, 8, 14, right? But look at the others. Do you see duplicate X values, Audrey?
No.
You don't? What about B? You see duplicate X values?
Where is B?
Right here. What about B? What are the X values for B?
I don't see B here. Where's B?
What are the X values right here?
You mean in the circle?
No, I'm over here, number 4.
Oh, I got
Do
number
you see
4.
number 4?
Okay, wait.
It's on the left side of my screen.
Okay, yes, I got number 4.
Okay, now, do you see any duplicate X values? Remember, the pairs are X, comma, Y. Are there any duplicate X values for B?
No.
You don't see duplicate X values?
Yes, they got 2 3s.
Yes, that's right. Very good. There are 2 3s. What about C? Any duplicates?
Yes,
What are they?
1
And what else?
and 3.
And 3. So you got duplicates 1 and duplicates. So this cannot represent a function. But the one Latoya said, A, no duplicate. All your X values are unique. 3, 5, 8, 14. Don't worry about your Y values. They could all be the same, but we don't care about the Y values when we're trying to determine if it's a function. It's the X values. So you just look, if you see duplicates, then you know it can't be a function. That's pretty clear cut, right? Duplicates, and if the signs are different, the same number, they are different. Okay,
Okay.
so that's number 4. I think we had, let's see, okay. All right, let's go to number 5. Number 5, can you see that? Can you see number 5? Okay, you bring it up some, just see it all, okay. Now here's the function. 1, 2, 1 and 2, these are ordered pairs. 2, 4, 3, 6, 4, 8. That's the function. Now, which of these do not represent the correct function representation of this function?
Oh,
In other words, this is the function. Let's see. I can copy it.
oh my goodness, I see something right here. It does something.
Okay, let's just copy that. That's the function. Well, no, then you won't be able to see it. Okay. All right. Now, what are the X values in this function, Latoya?
5, yeah, 5 or 6.
1, 2,
3,
What are they?
3, 4. 1, 2, 3,
1.
4.
That's right. Those are your X values. 1, 2, 3, 4. And your Y values are what?
2, 4, 6, 8.
Okay. Now let's look at this diagram where we're ordering the pairs in this kind of a setup, right? Now, are your X values the same here as here? Are your Y values the same? Audrey, are they the same?
I'm trying to get it up. I ain't got it yet.
Are these are the X values here. These are the Y values. Are they the
Okay.
same as they are in this function?
This is the part that says C and D. I don't know if I got the right thing.
No, I'm
Where I
looking
am.
at A,
You're on the left hand or the right hand side?
right side.
Because the light screen still showing me that checkered thing.
You don't see A, X, a circle with 1, 2, 3, 4, and then Y.
I see
2,
D.
4,
I see
6, 8.
D, Y, 2X, and the domain is 1, 2, 3, 4. That's where you at?
Number 5.
I don't know if there's number 5. It says X is a natural number less than 5 and Y is twice X. That's what you mean?
Well, that's C, but there's a B and an A before that. You don't see
Oh,
the
let
A.
me see. I ain't got that yet. Let me see.
You don't see the A and B.
Oh, okay. Okay, I see a A.
And
Yeah,
okay,
number 5.
and what is
Now
X?
we got number 5. Okay.
What is the X values? What are the X values
X
for A?
for A.
Right here. What are they?
1, 2, 3, and 4.
What? Yes. What are the Y values?
2, 4, 6, and 8.
Now, does that match what's right here for the function? That Latoya just said the X's were 1, 2, 3, 4, and the Y are 2, 4, 6, 8. Does that match?
Yes.
Yes, that matches. So that's a correct representation. All right. Now,
Mhm.
let's look at C. Is X less than 5, Audrey? In this function, are the X values less than 5?
Looking at C.
Yeah. Look at your functions. Are all these X values less than the number 5?
Yes.
Yes. Is the Y value twice the X value? Is the Y value 2 times the X value? In here,
Excuse me, Barbara.
yes,
Okay.
I'm going to leave the office now, so I'm giving you all right.
okay,
Okay.
all
All
right,
right.
thank you.
You're
All
welcome.
right, now, Audrey, are the Y values twice the X values in every case?
No,
Which one is not?
the 4 and the 3.
No,
I'm
no.
not sure.
The X, these are the X's, right? 1, 2, 3, 4. These are the Y's, 2, 4, 6, 8. In every ordered pair, is the Y value 2 times the X value?
Yes,
Yes, because 8
Yes.
is 2 times 4, right? 6 is 2 times
Yes.
3, 4 is 2
Mhm.
times 2, and 2 is 2 times 1. So C is a correct representation. All right, Latoya, what about D? Is Y equal to X? And the domain is the X values 1, 2, 3, 4. Is that a good representation? No, she's probably, oh, Audrey, D, is that correct?
wait.
Y equal to X. And the domain is 1, 2, 3, 4. That's your X values. Is that correct?
Yes,
Yes, because we said Y is twice X, and Y equal to X is Y equal twice X. And the domain, which are the X values, or what? 1, 2, 3, 4. Now, the one that does not represent is this graph. Now, I don't know if you can see this. Okay, this is a 2. When X is 2, what is Y? I'm right here. Can
Oh,
you
let me
see
see.
it?
Yeah.
When X is 2, what is Y?
X is 2. You mean on the graph?
On the graph,
Okay, let me see. If X is
that
2.
that dot right there, that's what? 2 and what? 2 and 1. That's a 1.
1. Okay.
So that's a 2 and 1, right? Well, we can say right away, we can see right away it doesn't represent, because when X is 2, Y is a 4. So we know this one doesn't represent, but we can go all the way through it. When X is 2, Y is 1. When X is 4, Y is 2. When X is 6, Y is 3. When X is 4, Y is right here. That's a 4.
4. That's a 4 there.
2, 3, 4. No, that's when X is a 3. Well, let's see. This is 1, 2, 3, 4, 5, 6, 7, 8. When X is 8, Y is 4. So actually this graph is representing the reverse, right? It has a 2 and a 1, a 4 and a 2, a 6 and a 3, and an 8 and a 4. So it has the X where the Y is and the Y where the X is. So this answer would be B. B is not a representation because the X values don't match the X values. They have the X values matching the Y values and the Y values matching the X values. So the correct answer would be B. Any questions on number 5? So 5 answer would be answer B. That would be the one, the graph is the one that does not represent. Okay. Okay. All right. Now, let me go to a new share. Okay. All right. Now, this is some practice for you. I want you to do 1, 2, and 3 and tell me what you get. I'll give you a few minutes.
The one that say a function and function notation.
Yeah, I'm at function notation, explanation, and examples. And I'm first just indicating if these following relations are functions, something we just went through, okay? So do 1, 2, and 3 and tell me your answers. You say yes, function, no, not a function. First one, Audrey, is that function or not a function?
Yeah. Number 1,
Function or not a function?
yeah, it's a function.
Okay, that's correct. Function.
I can't do next one yet.
Okay. All right. Then I think Latoya must be clocking out or something because she's not there. Okay.
Okay, number 2,
Yes. It's function or not a function?
I would say not a function
Why?
because it has 2 zeros.
Oh, but that's not the reason though. You can have zeros.
Oh, yes, yes, it has 2 ones.
2 of minus ones. Yes, it's
Sorry,
you have
two-
duplicates on the
duplicate
x's, the
of
minus
X.
1, minus 1 here,
This one,
minus
let's see.
1 here. So it'd be not a function. Oh, you can have zeros. Now on the grid, the zeros would be both at the origin, right? It's 0
Yeah.
x and 0 y. That would be at the origin. Okay. Give you a chance to look at number 3.
This is not a function. It has 10.
It's
And then it has,
number 3. Is it a function or not a function?
it's not a function.
Why?
And it's because it has a duplicate of 10 twice.
Yeah, but that's a y. Remember, Audrey, I said we don't care about the y's. It's the x's.
Oh.
Remember? I said don't worry about the y's. They could all be the same. But it's the
Oh.
x's that have to be different. Do you see any duplicate x's?
No,
No. So that's a function.
that's a function.
That's right. That's a function. Very good. Okay. Don't worry about the y's. You got 2 10s here. We could have had 1 here, but all your x values are different. You don't see any duplicates. 2, 9, minus 4, minus 8. Okay.
Okay.
Now we're going to do some function notation, but Audrey, you weren't here, so I better do a practice one before I give you one. Okay. So what we will do is we will take some functions, we'll plug in some values and determine what the function is. Okay, so let me just suppose I have f of x equal 3x plus 9. And I ask you to find f of 2. Now, what this means is wherever you see an x in this function, you're going to put a 2, Audrey. That's function
Yeah.
notation, all right? Wherever you see a X, you're gonna put a 2. So you take this function, let's copy it, and substitute for X 2. All right,
Fx.
okay, that here. So we gotta put a 2 here for the X, so that's 2.
Mhm.
And 3 times 2 is 6 plus 9. So what's that equal to, Audrey?
15.
15. Very good. Okay. So that's what we do with functions. We can substitute in for the variable and then solve the function. And it's like saying y equals 3x plus 9, where x is 2. We've been doing that before, but we weren't calling them functions. So 3 times 2 plus 9 equals 15. Okay, now let's do another one. Okay. Okay, let's say f of x equal, let's see, I want to copy something here. Okay, I want to copy a square. So I'm putting another one here for you to practice on before you start doing the ones I have here. Now this is equal to, and I'll say 2x squared plus 3x plus 10. Now, wherever you see an X, you want to put in, okay. And I want you to find, take this function, find f of -3. Okay, now wherever you see an X, you want to put in a -3. Okay, so
Wherever there's an X.
yes, wherever X in that function, I want you to put a -3. Okay, so let me just copy this over here so you'll have room to work with it. Okay, so Audrey, find f of -3. So that means you'll copy this and substitute -3 wherever you see a X. So this would be really f, and I can just put it here for the X. I'm substituting a -3. And wherever you see the X, put in a -3. So you're going to put a -3 here, right?
I ain't seeing your side though. I ain't seeing you put it.
I'm on
Oh,
the
yeah,
other
yeah.
side. I'm on the
On the
right
other
side.
side.
Okay, so I'm putting a -3 for the X. So there's a
So you got
-3.
that.
Okay, and that's going to be squared, right? So let's just
Mhm.
take
Square.
out the, okay. And then we have a -3 here for the X. See, we had it 2 places here, right? -3.
That's 3.
Okay. Now do the math, Audrey. What do you get for the f of -3?
Plus 10. Okay. So that is 2.
So -3 times a -3 is what?
3, 0.
No, -3 times multiplication.
Oh,
-3 multiplied by -3 gives you what?
-9.
9, not negative now. Minus
No,
times
not-
minus gives you plus. So this would
9.
just be a +9, right? So let's just take that out. Take out the square. Because we
Okay.
squared it, all right? And a 2 times a -3 gives you what?
2 times
3 times minus 3,
is 9.
plus or minus.
9
Plus or minus 9.
plus 9.
No. Unlike signs multiply to give you negative,
Negative 9.
like signs give you positive. So that's going to be a negative 9.
Negative 9.
Okay. So f of 2 times 9 is what?
18.
18. So let's just put that there. 2 times 9 is 18. Minus 9 plus 10. What is that equal to?
It's 19.
That's right. 18 minus 9 is 9 plus 10 is 19. Okay. So
Alright, just rewrite that.
this is substitution of the variable. The function notation is, way we read this is f of x equal to an expression. All right. And we can substitute values into our for the variable and then calculate the value of the function. So if if you put that in for what your variable is, that tells you that's what you're going to substitute for the variable. F of minus 3 is 2 times minus 3 squared. That's from here. 3 times x, 3 times minus 3. And then do the math, and that's what you get. Now I have some here for you to practice on. And I want you to find f of 0, f of 2, f of minus 4, f of 3t. Wherever you see an x, you're going to put a 3t. And f of x plus 2, wherever you see a x, you're going to put a, wherever you see a x, you're going to put x plus 2. Okay, so do those.
All right, give me that again. You see that, Ray? See that?
Okay, okay. So when I say f of something, an expression, whatever that expression is, you're going to substitute it for the variable, Audrey. So the x plus 2 will be put here for the x. The
X plus
3t,
2.
yeah, that would be put there for the x, and then you're going to square it,
X plus 2.
and it's going to be
X plus
squared.
2 is squared.
Yes, because x is squared. So whatever expression you put for the variable has to be squared. Just like 0 would be 0 squared. 2 would be 2 squared. Minus 4 squared. 3t, 3t squared. Now x plus 2 squared. Okay.
Okay.
So start with the a, f of 0. And plug it in all cases using this function. F of x is 3 minus 2x.
Okay. X minus 2x.
F of x is 3 minus 2x squared. Wherever you see an x, you're going to put what
Okay,
is
so
in this expression. So I'll just get you started here. F of 0.
So you say that the 0 is square.
Put the 0. Okay, f of 0. So we say f of 0, right? And wherever the x, you're going to put the 0.
It says 0 square.
Substitution. That's right, because the x is squared, right? So we take
Okay,
out the
and
x and now calculate it.
F of,
Calculate what that is.
F of 2 is 2 square. Okay. Okay, and F of
Remember
2
that 2 is multiplied times 0 squared.
the what?
When you square the zero, what's 0 times 0?
0 times 0 is 0.
That's right. What's 2 times 0? Audrey, 2 times 0.
0.
That's right. Any number times 0 is 0. That's
Is
like a
0.
0 rule. Okay, so your answer would be what?
I do it yet. I finish it yet. I know writing it down. It says 0 square.
Is
I know
0.
writing it.
And 2 times 0 is 0.
And 0 and 2 times 0. Wait, so 2 times 0,
Is 0.
right? And 2 times 2 is 4.
Now, where are you getting 4?
Oh my God. wait a
You
minute.
only squaring the 0, Audrey. 0 squared.
Uh-huh.
Because remember,
And two-
x is 0. So 0 squared is 0. Then 2
Uh-huh.
times 0 is 0. So then you will have what? 3 minus 0. Just copy this here.
I understand that.
Okay, let me go over it with you again. No problem.
You're talking about number like this that says 4f(x) 3x minus 2x
Right,
2.
I'm talking 3 minus 2x to the second power.
We didn't do it that
Okay,
way.
and and this has you
I know.
solving for f of 0, f of 2, f of minus 4, f of 3t, f of x plus 2. So the first one, f of 0, wherever there's an x in this function, you put a 0, which is what we did here. Substitute.
Fx,
Let me just put it here. What we did. Okay.
fx. You said the x is you put a 0,
That's right.
right?
Substitute.
And then the 2 now would be a what? We say put the 2.
Well, the 2 is a multiplication. So it's a multiplication by 0. Substitute
3 minus 2x.
substitute 0 for x. So that's what you did here. That's why where you have an x here, you put the 0. So the 0 is squared, and that's 0, right?
Okay.
And then see 0 squared is 0. Let's take that out. And 2 times 0 is 0. Right?
0.
I'm putting it in the steps here for you.
So he says f.
So 2 times 0 is 0.
3 minus
Okay.
2 0 square
And then 3 minus 0
equals
is, what's 3 minus 0, Audrey?
0. And I will get the problem there. We have to redo it because I started getting a little confused there.
Okay, you substitute the 0 for the x, and there we go, right here, right? So 0 squared was x squared, but we put the 0 for the x. So that's
Okay.
2 times 0 squared. 0 squared is 0 times 0, which is just 0. And that 2 is then multiplied by the 0. That gives you 0. And then what's 3 minus 0?
3 is 3.
It's 3. That's it. Very good, Audrey. So f of 0 is equal to 3.
Yeah.
So this one, let's put the answer here. A-N-S-W-E-R 3. That's the answer for that one. Okay.
E of 2 of 0 is 2. So that is 1, 2, 3, 4. This is 1, 2, 3, 4.
Are you okay with that f of 0, Audrey?
No, I ain't get it up yet. I ain't finished it up yet because I started how to delete something. Let me go over.
It's substituting. Remember, this is substituting the variable for the number that's in your f of expression. So f of 0 means put 0 wherever the variable is.
Fx equals to 3 minus 2x squared.
And where
So-
x is now 0, right here.
Shoot 0 for x.
That's
So
right.
this-
Substitute the 0 for x.
0
So that's why we put the 0 here.
is equals to 2 0 to square.
0 squared, 0 times 0, which is just 0, right? Right here.
0
And then any number times 0 is 0. So 2 times 0 is just 0.
Yes, 2 zeros. 3 is 2 0 is 3 0 and 3 0. 3 minus 0 is equals to 3. Okay, what happened if the one at the top now? Oh, that was it?
Which one?
Okay.
So we're still with the same function, Audrey. Now I want you to substitute a 2 for the x.
Okay.
Now do f of 2. So now where you have an x, you're going to put a 2.
Okay,
So
so that's
let me just copy that.
2.
Okay. I'll copy that here. Now you want to do a b, f of 2. So wherever there's a 2, wherever there's a x, you want to put a 2, because now we're finding the function when this value x is 2. So put a 2 there. Let's copy.
You put a 2
this.
where the x is.
That's
F-
right. That's right. So you put a 2, f of 2, and wherever there's an x, you're gonna put a 2. So you put a 2 here, and that 2 is squared, right? Because the x is squared, so the 2 is squared.
So you still doing number 4, Miss Barbara? I just got back on. I didn't realize you cut off.
Oh, yeah, I
You
know.
have to punch out and stuff from work.
Yeah, I said you had to.
Yeah.
Yeah, that's what I told Audrey. You had to clock.
Yeah.
Okay, so we're doing number 4, and 4 has parts, 5 parts where we substitute in different values. Now we just did f of 0. Audrey did that one. Okay, so wherever there's an x, she put a 0. So 2x squared is 2 times 0 squared, which gives you a 0, and any number times 0 is 0. So 2 times 0 is 0. So f of 0 is 3 minus 0, or 3. Okay, and now we're doing the next one, which is f of 2. So wherever there's a 2, you want to put, wherever there's an x, you want to put a 2. So now we are over here and solve that. What do you get, Latoya? You solved it? What is f of 2 equal?
Two square equal 4.
That's right. That's 4. So let's put a 4 here. All right. And we squared it so we can take out that square. Okay. And what do you get, Latoya? What's 2 times 4?
8 minus 3.
Okay, let's put here. So that's 3 minus 8. Right? What's a 3 and a minus 8?
A minus 5.
That's it. Audrey, did you get that?
No.
F of
We
2.
subtract the 2 from the, okay, she says, the one where it says F of 2 equals 3 minus 2.
3 minus, and then we substituted X for 2, right? Because that's F of 2. And 2 squared is 2 times 2 is 4. And then we multiplied it
Oh,
by
yes,
the
it's
2,
yes,
right?
it's
We got the
great.
minus 8. Then a
Minus
3
eight.
and a minus 8 gives you a minus 5. Because when the signs are different, you subtract and take the sign of the bigger number, which is the 8. Or you say you have more minus than positive. So your F of 2 would be a minus 5.
Okay.
So let me go here and put answer.
Plus 5.
SWER is a minus 5. Now keep going. Your next one is F of minus 4.
See that 5.
Same function. Wherever you see an X, put a minus 4.
I don't see it, Miss Barbara.
Which one you don't see?
The one that you just said.
Okay. All right. Let me put the function here.
Damn it.
Okay. Let me go back up here. Latoya, number 4 has parts A, B, C, D, E. You see this?
Something wrong.
You see that? Latoya, you see these? F of
Yeah, I see
0,
them.
F of 2. Now the C is F of minus 4.
I know what don't happen here.
No, so it's gonna be
Same function. Substitute. This is F of minus 4. So let me just put F of minus 4. So F of minus 4. Let's put it here.
Yeah.
Minus 4. Okay. Wherever you see an X, you want to put a minus 4, right? So put your minus 4 here and then square it.
Here.
And what do you get?
Oh, see here.
16.
Same thing. I see
16.
What do you get for
One,
F
two,
of
three.
minus 4?
16
minus 4x.
minus
Minus 4
16
squared, that would be a plus 16, right? So that would
plus
be a,
16.
yes, so we just put 16 here. And we've squared it. Okay, so what's F of minus 4? Got an answer, Latoya?
30, 16.
What's your
Oh,
final,
six-
what's your final answer?
16 times 2
Is what?
is 32
That's 32. Right?
minus 33.
What?
32 minus 3. Sorry, saying the wrong thing.
So what's the answer?
29. 20. No,
Remember, it's
29.
plus or minus?
A minus 29.
Minus, that's right, because you're subtracting, because it's a plus and a minus.
I don't like word problems. I could never get that.
3 minus, okay, so 3 from 12 is what? 9. So you get a minus 29. Did you get that, Audrey?
Okay, I now finishing up.
Did you get a minus 29?
3 from 12 is 9. And 1 from 3 is 2. Oh, yes.
Did you get the right answer?
Yeah.
Okay, so that F of minus 4, the answer, we got minus 29. Now the next one is 3t.
Okay.
So do that one. I want you to do that one. I'm not going to do it. I want you to do it. Okay. So Copy your function. Wherever you see an X, put a 3T. There you go. Let's just copy the function.
Now a 3T.
Yep.
FX.
Okay, wherever you see an X, you're gonna put the 3T. So this is gonna be, and I'll just put the 3T here, and then you solve it.
FX.
So that's F of 3T. So put the 3T here. 3T. And for the X, you're gonna put a 3T.
No, that's 5. And number 6 is. Oh man. I see that.
All right, now solve it. Tell me what you get.
That's the teeniest thing. I see that. Oh, I will get there. I will get to it.
What is F of 3T equal to?
Okay, wait a minute.
A minus 15.
X equals
What do you get, Latoya?
A minus 15.
What
3
do
3
you
is
put?
9. 9 and times 2 is 18 minus 15.
What are you doing with your T's?
3t squared.
3T
Oh.
squared is what?
Oh, it's 27. Sorry. So 3 9s. 9, 18.
What's your final
Where's the
answer?
T? 9. And 9 2 is 81. Yeah, right, yeah.
3T squared is
81.
what, Latoya? What's 3T squared?
You know. 8 9
9.
9 what?
90.
You got to square the T and square the 3. So what does that give you?
81.
No, 3T
9.
times 3T.
9.
9 what?
90.
What's T times T?
1.
Oh, T times T? It's
It's
T,
T.
T squared,
T squared.
right? So this
Yeah,
is going to
9T
be
squared.
9T squared, right?
Yeah, 9t squared.
Be careful.
9T.
9T squared.
Uh.
So you just take this parenthesis out. Okay, so that's 9T squared. Okay,
Minus
we put that parenthesis.
2.
Okay, so that's what you got. 3 minus 2 times 9T squared. What is that equal to?
T.
18. T squared.
92 are 18.
So you still got 3. 2 times 9T squared is what, Latoya?
18.
18 what?
18T
T
squared.
squared.
18T squared.
Yeah,
Okay,
18T squared.
18T squared. Okay. And that's your answer.
Oh. This one I didn't get it. I'm still
No,
like,
well, I said F of 3T. So wherever you see an X, you're gonna put a 3T. So that's 2X squared becoming 3T squared. 3T substituted for the X. Got it? Questions? Substitute for X, 3T. There we go. And X is squared, so 3T will be squared. That means you square the coefficient, you square the variable. 3 times 3 is 9. T times T is T squared. And then of course you've got a 2 in front of it, multiply it. 2 times 9 is 18. So it'd be 18T squared. And so your answer would be 3 minus 18T squared. That would be your answer. Let's put it here. So I'll put the answer. Okay. So this one, answer. (18 minus t squared). Okay. Let's see. What was that? 18 minus. What's the answer? Just type it in. Go back here. 18. No, 3 minus 18 t squared. Minus 18. That's t squared. So you got one more. Okay. Now, wherever you see an X, you're going to put an X plus 2. So you're trying to find f of X plus 2.
Fx plus 2.
Yep.
Fx.
Okay.
Oh, so you put that one. Fx plus 2. So you put that.
So wherever you see a X, you're going to put an X plus 2. So let's go back. Here's our f of X. Let me copy that. And you substitute. So wherever you see an X, put X plus 2. Plug that in. And that means you're going to square that X plus 2.
Fx. Fx. You said a square the X.
You're going to square the X, but the X is not X plus 2. So you'll have 3 minus 2. And instead of X, you're going to have X plus 2. And of course, that's squared. Let's put this here. Okay, so do the math. 3 minus 2 times X plus 2 squared. So that means X plus 2 times X plus 2. Then multiplied by 2 and then subtracted from 3. So I want you to complete that one.
X plus 2.
X plus 2 times X plus 2.
It's gonna be X squared plus 4.
No, X plus 2 times X plus 2. Well, let's just put it here. So you,
Plus 2 times.
okay, X plus 2. I'll just put it like this. Okay. This is the way this looks. Okay. This is times itself. So that's X plus 2.
So it's not x squared to the fourth?
No. See, when you
Different.
square in this, you'd have x times x. You'd have
X.
2 times
Two
x.
times two, 2 times
All right.
X.
So it's gonna be x plus 2x plus 4. That's how it is?
Well, you have first,
Second and third.
inner, outer, and last. First, inner, outer, and last. Now, there's a mnemonic for that, right?
It's called a function.
You have first, inner, outer, and
It's foil. Last.
FOIL is foil.
Foil.
That's right.
Yeah,
Right,
foil.
you know that.
FOIL to help you remember it.
And two,
So you have first,
yes,
that would be your
two.
x squared, right? Then you have your outer x and 2, and then you have your inner x and 2, and then you have your last 2 times 2. So what does that give you, Audrey?
We'll get to that part yet.
Well, we know we have an x squared, so let me copy this x squared.
That's 2.
So you use your FOIL. First, you have
X squared.
x times x is x squared, right?
Yeah.
Okay, the outer is going to be x times 2, right? So that, what's x times 2?
2x.
2x, very good. So that would be plus 2x, right? Then inner is going to be 2 times x, another 2x, right?
Yeah, plus 2x again.
That's it. And then the last is 2
Plus
times
4.
2. That's it. Very
Yeah.
good, Latoya. Okay, now let's combine those x's. And what does that give you?
It's
Well,
5x squared.
2, 3.
No, where are you getting 5? You only have
3.
x squared once.
3x squared.
Oh, 4x squared.
What do you have, Audrey? Combine the
I
likes.
have
What do you
three-
have?
I have 3x squared.
Where are you getting a 3? X squared only appears one time,
X squared
you
is
have-
1 time.
but you have
Plus 2.
the 2x. You can combine those. What's 2x plus 2x?
It's 4x.
That's it. Just add the coefficients, right? So that's 4x. So we can take out that 2x because we added it. And you have x squared plus 4x plus 4.
X squared.
So the x plus 2 square is x squared plus 4x plus
4x.
4.
Plus 4.
Okay, so you plug that in, multiply it by 2.
So 2.
Okay. So this is when we squared this, we got this expression. So let's just put that here. Okay, and that's in parentheses. Okay, and this comes out because we squared it, right? And that's in parentheses. So multiply that out and combine your like terms. So what does that give you, Audrey? We multiply this out.
2x plus 2x.
What do we get? Multiply 2 times everything in parentheses. What do you get?
2x.
2 times everything in parentheses.
Yeah, minus 2
Mm,
times x squared
four.
is a minus 2x squared, right? That's it. And what's a minus 2 times 4x?
A minus 8x.
Very good. Minus 8x. So that'll be a minus. And that's a minus 8x. So let's put the 8 there. And what's minus 2 times a plus 4? Minus 2 times plus 4 is what?
8.
Plus or minus, Latoya?
A minus 8.
That's right. Negative times positive gives negative. So that would be a minus 8. Now, what can you combine here?
2x minus 8x.
That's an x squared.
Oh,
Can't
no,
combine
3
that.
minus 8. 3
That's
minus 8.
it. You can only combine those constants. Yes. So that would be
A minus 5.
that's it. So minus 5. So let's put here a 5. That's what we get from a minus 8 and a plus 3. So what's our answer? Minus 2x squared minus
Minus
8x minus 5.
Minus 5.
Minus fx plus 2 is minus 2x. Minus 2x squared.
So that's the answer to f of x plus 2. So let's just put that answer there.
F. I'm gonna have F.
So this answer so that's the answer for E. F of x plus 2, that's E. Okay.
Functions is hard, Miss Barbara.
But you just practice them.
Yeah, I
I
still
mean, the more
don't get a lot
practice
of
is,
this.
yeah, the more practice you get, the better. We'll be doing some more practice, but I just have one homework. I just want to see how you'll do on this one. It's just one homework. And let's see. I'm giving you 2 functions. Okay, this is the homework.
You say, what is a function?
No,
That's what I saw in the bottom. That's why.
no, that's not it. This is the homework. Evaluate this expression.
When f of x equals 6 plus 1.
This is your homework. Okay. One question. I gave you a function and I want you to find f of 2. And I also want you to find f of 1 and then subtract them. And
But it's a plus right here. 6 plus 1.
what's the, I'm sorry?
What is the
Oh,
function?
it says 6x plus 1 if it's minus.
No,
Wait a minute.
f of x, where f of x is 6x plus 1. So if you do an
Where's
f
that?
of
Let me see
2,
that.
you're gonna put a 2 for the x. If you do f of 1, you're gonna put a 1 for the x. And then you're
that's
gonna
what I
subtract
mean.
them. Yes.
Oh, because I didn't understand. I keep looking at it for a while now, and I was like, what the hell is this? I don't understand.
Evaluate f of 2 minus f of 1, where f of x is 6x plus 1. So wherever you have an x, you're gonna put a 2. Then you're gonna also do a f of 1, and then you're gonna get the difference. Any questions on the homework? One problem.
So this is one problem, but it have 2 parts. That's what you mean, right?
Yes, is you finding the value of a f of 2 and a f of 1, and you getting the difference.
Hmm.
Oh,
So you're gonna get numbers here. All right, no variables, because once you put in a 2, then that becomes a number. And once you put in a 1, that becomes a number.
yeah.
So you're gonna find a f of 2, f of 1, and then subtract them. That's your homework. All right. And we'll continue practicing next time. I think the more practice, the better you'll do on these, because I was going to go to the composite functions, but I said, no, I don't want to go there yet until we get this down, because composite function is a function of a function.
Yeah,
Okay.
that's hard.
That's a little more involved. So we'll do some more of these before we get to the composite function, which is a function of a function. You've probably seen them, like a f of x of g of x. All right.
No.
But we won't get to those yet. We got to do some more practice. Audrey, any questions?
Hello.
You did good. We missed you, right?
trying.
Right, Latoya? We missed Audrey.
Yeah, I
Haven't
wonder
seen
where
her
she
no-
went. I thought she went to our country.
No traveling, no traveling.
No, she had some problems
with
with buses and
bus
getting her
and getting to the
timesheet
office.
in and all.
Without
Yeah.
what I'll be staying
But
put
all
for a
she do,
little while.
email it. Take a picture on her phone and email it.
I ain't good at that yet.
No, it's easier that way. You just need to press it down on something, look for the camera up on your phone and get the email for the agency. 1, 2, 3. As long
You
as
don't do
have
it, so
the
you gotta
email.
take it in. You gotta stamp it.
Oh,
Oh, please.
they had the old way, Latoya. They
Yeah,
haven't
they got-
upgraded
yeah.
yet.
I
Yeah.
would like my agent if you tell me that, please. I send my
Oh, they
stamp
could
sheet.
save you a trip, because you know you could even scan
But
it.
Audrey, you gotta tell them you're in school. You gotta tell them you're in school. You have classes start, and they will understand. If you don't speak up, they don't know. They
I'm
think
sh-
you have
I'm-
time
I'm-
free.
Well, you know what? A lot of time they think you can't do it the automated way. You tell them, of course I can do it. And then
not
you
that,
save
it's
yourself a
Audrey tell-
trip.
Miss Barbara, if Audrey tell them that she's in school, they will make adjustment for her. She didn't tell them.
I'm sure they
They-
will.
Then they did.
they-
Then it was going to be. Then it was going to be. Or see, they didn't tell me that though. It is sticking out that I must work. I must do my work on Friday evenings. When no Friday evenings is my sundown time to for church. They never do it. They never do it. I carry letters and letters and letters and nothing. They never would do it.
But things change.
I know. That's why I'm telling you now. Things change. A lot of things may change.
Well, that's what I tell you now. Tell them say you're in school.
Mm.
No, for real. Tell them you're in school. Tell them, listen, your professor say you can't be late. So you have to email it. It's not a big deal.
You can't change people rules.
No,
Trust me,
they make adjustments.
They
Audrey.
make adjustment, Audrey,
They
because
do.
my
They do it
patient
all the
phone wasn't
time.
working for a long time, and they tell me, oh, I gotta come pick up gloves too and masks, and I was like, yes, Vic, I'm gonna pay $61. I don't take the buses to come to the thing, and they was like, oh, we can't find nobody.